Hello everyone. Today I want to just go through a quick review of some of the questions that followed our first atmospheric layers video in our booklet. And possibly these will help you out in some of the check-ins that are coming your way. So why is the bottom of the troposphere warmer than the top of the troposphere? So when we think about why the bottom of the troposphere is warmer, it's because it is closer to the ground, so there can be some conduction of energy from the ground into the air. Remember that the ground absorbs all of the radiation from the sun, or the majority of it, because the ground is much more dense than the air. So there's a lot more particles to catch that radiation. So that's why a large portion of the radiation gets absorbed by the ground. And maybe we should put a little note here. Don't need to write that big because I'm over here. So remember that the ground absorbs most of the radiation from the sun, so it is always warmer than the air. Might not always feel that way, and maybe sometimes you'll get a warm wind in, but technically it is absorbing more of that temperature. Now, of course, heat capacity takes a role in there about how it actually feels to your touch. Ozone is a chemical that absorbs ultraviolet radiation from the sun and stops it from reaching us on the Earth's surface. Why then would the temperature of the stratosphere increase as your altitude increases, as the graph shows? So the graph they're referring to, let's see if we can scroll up a little bit. So right here, so they're talking about right in this zone here, we can see that the temperature is rising as we get closer to the stratopause. And the reason this is happening is because the ozone layer is absorbing that radiation, right? So that radiation is coming in, and then it is getting absorbed. And so that means that the radiation is absorbed by this first layer of the ozone, and then a little bit of it moves forward, and it gets absorbed, and then a little bit gets absorbed. And so there's less and less radiation that gets through. So the majority of this radiation gets absorbed by the ozone layer at the top, and then as it gets absorbed, there's less of it for the lower layers. So the top of the layer is therefore heated, while the bottom layer is getting less radiation, so it is less heated. How many kilometers thick is the troposphere? We did discuss this. It's about 10 kilometers. What is the temperature at the top of the troposphere? It's minus 50 degrees Celsius. Why do our infrared satellite images show large storm clouds have a temperature around minus 60? This is a really interesting question. I had to think about this for a little while. Think about how the storm clouds contain water. And water has a higher heat capacity than the air around it, and they're also denser than the air around it. So the same amount of energy does not have the same effect. So actually, that's probably the bigger key point. The dense storm clouds have taken this energy, but taken the same energy as the air around it, but it is spread over more molecules. So the cloud is colder. So think about it this way, that you're getting the same amount of energy from the sun, or from wherever this is getting, as the troposphere, right? So it's getting the same amount of energy from the convection from the Earth, but because it's more dense, that energy is going to be spread over more particles. So the same amount of energy over more particles equals a cooler thing. Also, the formation of clouds takes up some energy, so you lose some energy there as well. How do you recognize the stratopause, mesopause, thermopause from the graph and the figure? Each pause is the point where the temperature is changing directions. That's one way. It's where the temperature is constant. So the tropopause is going from a cooling to a warming state. The stratopause is going from a warming to a cooling state. Mesopause, cooling to heating, etc. Here's some questions. You might have had to do some research to answer these ones. So the ionosphere is at the top layer of the atmosphere, and it's where the gas molecules are ionized by the energy. So here we're not defining the layer by the temperature, but by the composition of the chemicals. So that's why the ionosphere is at the same layer as the top layer. And that's because it is at the same layer, but it's referring to the type of molecules. It's around the same height off the Earth, but it's about the type of molecules we have there. So there we have molecules that have been ionized. And we also have the magnetosphere, where the magnetic waves are important. What is one advantage of the ionosphere that has regard with radio transmissions? Well, it is not very easy to send radio through the ionosphere. It blocks certain types of radiation waves, and it actually will reflect them. So what we can do is we can take this idea that there's this huge sort of shell on top of the Earth that is the ionosphere. And we can take a satellite dish over here. So we can take a satellite dish like this, and we can fire a radio wave up, and then that radio wave will come back down so that we can have another satellite dish that accepts that radio wave, and we can get very long distance communication. And this has been done since the 1920s. So since the 1920s or so. 20s. We've been doing that sort of thing. It's a 2. The ionosphere, but unfortunately the ionosphere can block satellite transmissions depending on where your satellites are. So if you have a satellite like this, it might be there might be interference between the ionosphere depending on how dense the ionosphere is at that time. So you can get reflection of waves from the satellites, and that can cause interference, and it can cause interruption in service. So if you're trying to send a message via satellite, it might not function if the ionosphere is particularly active at that point. The aurora borealis occurs in what is known as the magnetosphere. It's on top, and it's the same area as the ionosphere, it's the same area as the thermosphere, but it extends farther along with the ionosphere. And it takes those ionized particles, and those ionized particles are affected by the magnetic fields of the Earth. And then if you combine that with the energy from a solar wind, the solar wind and the magnetic fields can cause the ions to become more of a plasma, where the ions have some interaction due to the fact that there are positive and negative charges up there, and those positive and negative charges are moved together in a certain way that creates those very beautiful imagery we see in the aurora borealis. And then the gases that we see in the atmosphere, you can look these up anywhere or in one of the videos that we've posted. 78% nitrogen, 21% oxygen, 0.93% argon, and 0.04% carbon dioxide. Each one of those has a different effect on weather. Nitrogen and oxygen have the least effect, but carbon dioxide and water, which we don't list here, are two that have a very big effect on our weather. Which gas is most prevalent? Nitrogen is most prevalent. And in fact, if we had a higher oxygen environment, we would have a very different plant life, very different animal life on Earth, because it's oxygen that really controls the life of those organisms. So did you know we think of the Earth's atmosphere as being pretty thick? After all, the top of the thermosphere is roughly 100 kilometers high, but compared to the size of our Earth, it's very thin. The atmosphere surrounding the Earth is similar in relative thickness to the skin surrounding an onion, and our atmosphere is delicate. Do we treat it with the respect it deserves? Well, that's a question to think about. At one point, when we were using a lot of chlorofluorocarbons, which were CFCs, these were used in heating and cooling. Particularly in air conditioning, air conditioners and fridges. It was a refrigerant. Fridge. So the CFCs were used in these, fridge, and then they were outlawed in about the 80s or 90s or so, and they were outlawed because they were found to be breaking down the ozone layer. And since outlawing the CFCs, we've seen the ozone layer rebound, and it's become much stronger than before. Certainly when I was going to school, there was a lot of talk about the hole in the ozone layer, and we were wondering if we'd done irreparable damage to it. And now it has repaired itself and is much stronger than it was before. And that's important because it stops a lot of those harmful UV rays from getting to the planet and heating it up in a way that would be damaging. Anyways, hope you had fun with this video, and we'll talk to you in the next one.